Good afternoon, everyone, and welcome to our Careers in Marine Science session this afternoon. Thank you all for joining us. I'm sure we'll have a few more enter into the session as we come along. Today we have Professor Kylie Pitt. Kylie is our discipline head of marine science in the Griffith University School of Environment and Science. And so she's here today to tell us all about herself, her career, and potentially your possible careers in marine science. So just a little bit of a note before we start, feel free to ask any questions throughout the session in the Q&A column on your screen, and Kylie will answer those questions as she sees fit throughout the session. So over to you, Kylie.
Thanks for the introduction, David. So, as David said, my name is Kylie. I'm the discipline head for marine science at Griffith University. And I thought today I'd talk to you a little bit about what my job entails, and in particular focusing on the research that I do. I'll tell you a little bit about the career path that I took to get to my current position. And then I'll talk about the great diversity of jobs in marine science. So where a career in marine science might take you. So as an academic at Griffith University, I have essentially three roles. First of all, I'm a research scientist, researching the marine environment. I am also a teacher, so I teach undergraduate students, but also postgraduate students, so say students doing their masters or their PhD. And then, like most jobs, I also have a role in administration and in management. So as a discipline head, I manage the staff of marine scientists at the university, and I'm also in charge of the teaching program. So, for example, our Bachelor of Marine Science program. So, as a research scientist, I guess the one thing we're all incredibly passionate about is our research. And throughout my career, I've actually worked on different aspects of marine science. So, when I was an honours student, I was studying the ecology of larval reef fish up on the northern Great Barrier Reef. I've worked on the crown of thorns starfish. I've done work on marine protected areas and their role in conservation and fisheries management. But what I've been focusing on for about the last 20 or so years now is the ecology of jellyfish. And jellyfish might seem like a bit of an obscure topic to research, but in fact, jellyfish are one of the most important groups of organisms in the marine environment. They're one of the most ancient animals. They evolved more than 500 million years ago, and they've been forming blooms in our world's oceans ever since. So they're incredibly important in terms of the ecology of the ocean, and that's because they're really voracious predators. They eat lots of zooplankton and larval fish, but they are also incredibly important as a food source themselves. So, for example, many types of fish eat jellyfish, and also some birds, including penguins, eat jellyfish. And a lot of our turtles, even the iconic and enormous leatherback turtle, eat jellyfish. And in fact, the leatherback turtle only eats jellyfish. It's its only source of food. Jellies are also incredibly important in sustaining biodiversity in the ocean. So, for example, if you ever go snorkeling with jellyfish and you're able to actually look at them from a safe distance, you'll often see lots of little fish swimming around with them. You might see crabs crawling around on their bell, and you might also see barnacles and other things attached to them as well. So they effectively provide habitat for other animals living within the marine environment. So trying to understand their ecology, their role in the marine environment is one of the main areas of research that we do. But over the last few decades, jellyfish have also been a source of concern. And this is because they often have quite negative interactions with humans and also with our coastal industries. So many of you are probably aware that sometimes a day at the beach can be ruined if you get big blooms of blue bottles being washed ashore. But jellies also interfere with commercial fishing operations because the big blooms of jellyfish can actually get stuck in nets and damage the fish. They can get clogged in the cooling water intakes of coastal power plants and desalination plants. And they can even disrupt ships manoeuvring in port when they clog the bow thrusters of those ships. They can also be very detrimental for the aquaculture industry. So, for example, a lot of the salmon aquaculture in places like Ireland and even in Tasmania, they often have large sort of economic costs associated with jellyfish when these big blooms of jellyfish move through and sting all of the fish. So there's also very good reasons for studying jellyfish in terms of trying to work out how we live alongside them and how to minimise their impacts on coastal industry. So for all of these reasons, I've ended up with a career that's really been focusing on jellyfish. And I guess my career has taken me all over the world. So some of the places I've studied jellyfish are in the fjords in Norway, so in some really cold areas. I've also worked in Saudi Arabia, in the Red Sea, studying some of the jellyfish off there. And of course, I work all around Australia, particularly in Queensland, but also I have projects, for example, over at Ningaloo Reef on Western Australia. So the main areas of research that my team does is to look at how jellyfish populations might be responding to anthropogenic stresses. So they're stresses that are caused by humans. So looking at things like climate change, there's been lots of claims that climate change might increase populations of jellyfish. So we're really doing the science to work out whether or not that's the case. We look at how they respond to environmental stresses such as pollutants as well. So things like pesticides, microplastics, and all other stresses that we put into the environment. We also look at their role in biodiversity, so looking at symbioses between jellyfish and other organisms. And we also have a particular role in studying irukandji jellyfish. So you've possibly heard of irukandji. These are the really tiny little jellyfish. They're a type of box jellyfish. They're common in Northern Australia, and there's a lot of concern that they might actually be moving south as a consequence of climate change. So some of the research that we're doing is trying to improve our ability to detect these animals in the marine environment and to work out whether or not they might be moving south. So with the research that I do, the fieldwork that I do, it can be undertaken on research vessels. So, for example, we do some work on the Investigator, which is Australia's big oceanographic research vessel that you may have seen. It's usually down at the port, down in port in Hobart. So we do some work off the Investigator if we're wanting to work a long way offshore. If we're working closer to the coastal environment, we might work from one of our smaller boats. Sometimes we do some work from shore as well. And a lot of the work that we do, particularly the experiments that we do within the laboratory. And I guess one of the most exciting aspects of my career so far has been the development of the Griffith Sea Jellies Research Laboratory. So the Sea Jellies Lab is actually based out at SeaWorld as part of the Sea Jellies Illuminated exhibit, and it's possible that some of you have actually been through that exhibit. And what's really exciting about this lab is that it's probably the most well-equipped laboratory in the world to do the type of research that we do. And what's really special about it is that it has really a large number of what we call Kreisel tanks. So Kreisel is the German word for spinning top. And so these tanks create a circular flow of water that helps to entrain the jellyfish in the middle of the tank. And that's really important because jellyfish swim very actively and they're not used to being confined in a normal aquarium. So if you don't have that circular flow of water, then the jellyfish will simply swim to the side of the tank and keep swimming until it rubs a hole in itself and actually dies. So having these Kreisel tanks is actually really important. And we've got large numbers of Kreisel tanks in which we can manipulate different aspects of the water and the environment of the jellyfish, and we can look at how the jellyfish respond. And so by doing that, we're understanding a lot of aspects about how jellyfish respond to changing ocean conditions. So that's a really exciting component. The other really neat thing, of course, about our laboratory, and you can actually see the lab in the background behind me here, is that the lab is on display to the public. So it's a fantastic opportunity for the public to come and see the research that we do on display. You get a really good understanding as to what it is a marine scientist does on a day-to-day basis. So it might be that we're working at the aquaria, monitoring different aspects of our experiments. You might see us working at the microscope, for example, sorting samples and identifying specimens. So that's one of the aspects of my job that I really love, and that's the communicating science and engaging the public within science. So in terms of what I have, or I guess how I ended up as a marine scientist, and in particular as an academic, is I did an undergraduate degree, a Bachelor of Science with a marine biology major at James Cook University. And back when I did my undergraduate degree, James Cook was really the only place in Australia that was offering that degree. So that's why I ended up there. But fortunately now I've got multiple institutions, including Griffith, where you can actually come and do a marine science degree. So I spent 4 years there. I studied a Bachelor of Science, and then I did an extra year, which is the honours year. And the honours year is a final year of study, which is a little bit more like an apprenticeship. So you do a research project in collaboration with one of the teaching staff at the university, and it's like a really good introduction into research. So following my bachelor's degree, my honours degree, I then spent some time travelling overseas and working, and then I decided I wanted to do a PhD, and I moved to the University of Sydney to do that and spent about 3.5 years doing a PhD. And a PhD is, it's quite a particular pathway. It's a pathway that you take if you really want to go into a research career or perhaps into a senior management style career. So all in all, it took me about 7.5 years of study to end up in an academic position. But there's lots of jobs in marine science that don't require a PhD. So there are lots of job pathways that a Bachelor of Science or a Bachelor of Science with an honours degree tacked on will actually take you to. And a lot of the areas that our graduates end up working are things like as environmental consultants. So every time there's a development in the marine environment or along the coastal zone, an environmental impact assessment has to be done and a decision has to be made as to how or whether or not the development should go ahead, and if so, what restrictions should be placed on that development. And sometimes if we know the development is going to have some adverse environmental aspects, it might be that we need to decide what sort of compensation mechanism needs to be put in place. So for example, if we know that a development is going to affect a particular sort of habitat, it might be that the developer needs to fund the rehabilitation of another area of land to compensate for that. So environmental consulting is a really common and important place for marine scientists to work. You might work for organisations such as marine parks or fisheries, and within those organisations you might work in compliance. So you might be out there on the boats making sure that people aren't harvesting too many fish or taking undersized fish. You might make sure that they're not fishing within the marine protected areas, for example. Otherwise, you might work on the policy side of things. So you might be deciding how many fish are people allowed to catch, where should the marine parks be located, in which case you would probably be more office-based in making those decisions. You might end up working in environmental monitoring. So at the local government, so within our councils and also at the state government level, we have departments that are really involved in monitoring the water quality of our estuarine and coastal waters. So you might be monitoring things such as nutrient loads, levels of pollutants such as pesticides. And so you will be out taking water samples, analysing those water samples and generating reports and making decisions about what needs to be done in terms of managing those water bodies. You could also work in areas such as ecotourism. So if you've been out whale watching, or if you've ever been to a resort and gone snorkeling or done a reef walk, usually you'll be accompanied by a marine biologist, and the role of that person is to actually interpret what you're seeing for you. So they'll explain about the behaviour of the whales, they'll tell you what species of whale you're looking at and that sort of thing. So having someone who knows a lot about the marine environment and is able to explain what's going on really enhances the experience that the visitor is having to an area. Aquaculture is another very important area that is demanding a lot of people with marine science degrees. So aquaculture is the fastest food production sector or fastest growing food production sector globally. We now produce more fish through aquaculture than we do through the wild harvest of fish, which is a fairly amazing statistic. So aquaculture has really been on an exponential increase over the last sort of 3 to 4 decades. And in Australia, although we don't produce much of our fish by aquaculture, we are growing very, very rapidly in terms of the amount that we produce. So you might be aware that we aquaculture salmon down in Tasmania, and that's an industry worth hundreds of millions of dollars annually. It's a very, very important industry for Australia. More locally, you might be aware that we culture oysters in Moreton Bay. There are prawn farms around Moreton Bay, and in northern New South Wales we actually have a really unique aquaculture facility which is culturing slipper lobsters or the Moreton Bay bugs. So all of those industries also require people who have got really good skills in marine science. I guess another area that a lot of our students will go into is also teaching. So you may not necessarily think of teaching as a role in marine science, but we need people with a really good understanding of the marine environment to actually be teaching students, such as you, within our school system. So school teaching is also another pathway that you can take as a marine scientist. So if you want to do marine science, then you would normally do either a Bachelor of Science degree with a marine biology major, and we offer that at Griffith University. And the advantage of doing a Bachelor of Science with a marine biology major is that you can often partner that degree or that major with another major. So for example, a lot of our students will do a double major with marine biology and also wildlife biology or geography, for example. If you're really interested in marine science and want a taste of different aspects of marine science, then the Bachelor of Marine Science might be for you. So in the Bachelor of Marine Science, you'll get a taste of marine chemistry, you'll do some oceanography, you'll do some biology and ecology as well. And that's really for people who know that absolutely being a marine scientist is exactly what you want to do. And if you think about what are the really good things about being a marine scientist? Well, I think, as I mentioned before, the ability to travel around the world for your job is something that I really value. Often when you're travelling for work, you're going to places that are often really remote, and they're usually places that are sort of off the normal tourist destinations. So you're likely to see some places that are really unique and that most people will never ever get to visit. If you love being out on the water or under the water, then of course being a marine scientist is a great thing to do. Some of the jobs that we do require scuba diving. Not all of them do. It's not a requirement, and there are a lot of marine biologists who don't scuba dive. You might spend time out on boats as well. So if you like being out on the water, that's a great advantage. But again, there's a lot of marine scientists who get really seasick and never step foot on a boat. So again, being seasick or not enjoying being on the water is not necessarily detrimental if you've got a really strong interest in a marine science degree. And then you might end up in a position too, such as if you're working in policy or if you're a manager where you might be more office-based. So it's a really diverse area of jobs that you could actually work in. So I'm very happy now to perhaps open the floor to questions, and yeah, feel free to let me know if you've got anything you'd like particularly answered. So we've got one question that's come in, and that is, what subjects do we study during high school to get in to marine biology overall? Okay, so for the Bachelor of Marine Science degree and also for the marine biology major in our Bachelor of Science degree, the prerequisite course for those two degrees is English. Okay, so English is incredibly important for pretty much any university course. We also assume that you've got either Maths A or Maths B. So you will be doing some mathematics and statistics during your degree, so having that background knowledge in maths is also very important. And although it's not compulsory, we do strongly recommend that you have one of either chemistry, biology or physics. And either of those three, or if you can do two of them, that'd be terrific. And that will give you a really good basis for coming into the bachelor's degree. So when you're in first year, you will do some quite general courses. So you'll be doing some introductory chemistry courses, you'll be doing some introductory biology, some introductory mathematics. So having a background in those in your high school will set you up really well for succeeding in your first year of study. And I can see that Tilly has actually just put up a link to our marine science course. So you might want to follow that link and have a look at the prerequisites and some of the recommendations for entering into that degree. Okay. One thing I should note is that the entry requirements for the Bachelor of Science and the Bachelor of Marine Science are very similar. And quite often we find that students might enrol in the Bachelor of Marine Science and then transfer into the Bachelor of Science, or they might actually do the reverse. They might enrol in the Bachelor of Science and transfer into the Bachelor of Marine Science. So the first year that we do at university is common for both of those degrees. And that means that it's very easy for us to actually transfer between those degrees if that's what we want to do. So the way that the degrees are structured is that in first year, You do introductory type courses, and we also do an introductory marine science course, so you get that taste or experience in marine science right in first year. Then in second year, you start to do more specific courses. So these are courses that have a stronger marine influence. So for example, you might do a course called Coastal Environments, which talks about all the different types of coastal habitats that we have in the area, as well as doing some more advanced statistics courses. And then in third year, you're doing some very highly specialised courses. And in third year, we will also take you up to the Heron Island Research Station in the Southern Great Barrier Reef for what we call our capstone project. Now, our capstone project is a really exciting project. Effectively, you have to design your own research project. We spend time designing that before we go up to Heron Island. You've then got a week to actually collect your data, to test your hypotheses, work up those data, and essentially use all the skills that you've been developing throughout your undergraduate degree to do your own research project. And we do that right at the end of the degree, because it's a fantastic way of actually bringing together all of the knowledge that you've actually built up over those last 3 years of study. Okay, I've got a question from Robin here, and she asks, how strong is employability in the marine science field? Is it very competitive? Well, I distinctly remember as a student about the age of most of you will be now, and going to my career counsellor and saying I wanted to be a marine biologist. And she said to me, there are no jobs in marine science. Well, I actually really think that she was absolutely wrong, because I've never been unemployed for a day in my life. So a lot of people do think that there aren't as many jobs in marine science as in, say, some other fields such as nursing or teaching or that side of things. But I think the thing to remember is that Australia really is a marine country. So about 80% of our population lives along our coastlines. We have one of the largest coastlines in the world, and we have the 3rd largest area of ocean under our governance of any other country in the world. So Australia has incredible marine resources, and we need marine scientists to manage those resources, to learn how to extract value from those resources, either through fishing or through mining industries or oil and gas industries as well. And we even need people to actually, I guess, oversee the development of those coastlines as well. And with aquaculture being the fastest growing food production sector globally, there's going to be an increasing need for people with marine science. So when you think about a career in marine science, having a degree is just one aspect that you need to think about. So as you're doing your degree, you should also be thinking about what other skills you can actually start to develop that is going to set your CV apart from other students. So, for example, if you are someone who is a keen diver and you want to have a marine science degree that involves diving, then I would get your diving certificate as soon as you can and start to get some experience up, so that by the time you come to graduate, you're a really competent and capable diver. You might want to think about getting your boat licence, and perhaps your radio operator's licence, your first aid qualifications. And I'd really strongly recommend also volunteering throughout your undergraduate degree. Get to know some of the PhD students and academics who are researchers in your area, and see whether or not they might need a hand to do things. And again, that's all experience that you can put on your CV. So getting a job really takes 2 things. One, it's going to take your degree. But second, it's going to take all of these extracurricular activities and skills that you need to develop along the way. And if you put those 2 things together and come out with a really good looking CV at the end, you will find a job reasonably easily. Okay, here's another question. So does Griffith do a combined course of both environmental science and marine science? And would this be a recommended course to take for someone interested in conservation? Okay, so we've got 2 pathways for doing marine science, or marine, yeah. So we've got the Bachelor of Marine Science, and in that you can do what we call a minor in marine ecology, or marine chemistry, or resource management and conservation. But that's very much a marine focused degree. If you have a strong interest in conservation generally, then you might want to do the Bachelor of Science degree instead. And so you might do the marine biology major, but then you could partner that with a second major in, for example, wildlife biology. And that would give you the ability to gain skills in both the marine and also the terrestrial environment. And it means that when you come out of your degree, you can probably apply equally well for jobs in either terrestrial conservation or marine conservation if that was what you were really interested in. So as I mentioned, it's really, sometimes it's difficult to know exactly which degree to go into when you first start out. And because we have the common first year courses across both degrees, it means that you can actually change your mind. So you're not stuck with that original decision that you make when entering university. It's really flexible, and you might actually switch between those two degrees. Okay, yeah, Jen has actually just put up the list of majors that you can do within the Bachelor of Science. Okay, so you can actually see that some of those majors are specific to just the Gold Coast campus, such as marine biology. Some others are at the Nathan campus as well. So it depends on where you live as to what you can actually do. Okay. Okay, so I've got a question here. How do you get your diving licence and what process do you go through? Okay, so to get your diving qualifications, you would normally go and do a training program, usually through a dive shop. So if you just do a search on scuba diving shops, you'll come up with a whole list of them within the local area. Usually it's about a 4-day course. Usually it's done over 2 weekends, and you will start off doing some training in a pool, and then you'll progress to actually doing some dives out in the ocean. So when you're scuba diving, there are different levels of qualification. So you start off with what we call the open water certificate, and that gives you the ability to go and dive by yourself or with your friends. But if you want to progress further, you can then go and do what we call the advanced course, and then you could do a rescue diver course, and you could go right up and become a dive instructor yourself. Now, if you want to do research diving, then it's a little bit of a, well, it's not a different process, but you need some different skills. So if you come through as an undergraduate and you want to do some diving, then the best thing that you can do when you first arrive is to probably join the dive club and get a whole lot of diving experience. We also have a boating and diving officer at the university who oversees all of the diving work. And if you want to start, if you've got some experience behind you and you actually want to start helping some of the researchers with their diving, what you would need to do is to talk to our diving officer. There's a set number of hours of experience that you would need. You would also need to do a checkout dive with our diving officer. So he'll just do a dive with you and make sure that you're competent, and then you'll be able to actually start diving. But you'll need, usually we would aim for what we call the advanced qualification. So that would be the 3rd level of qualifying. And yeah, and that's an easily achievable target. So I encourage you to basically just get out there, get underwater, get some experience. That's the best thing that you can do at this stage. Okay. All right, another question. If I'm already experienced in diving, which courses should I take to find a career that also involves diving? Gosh, well, you could do just about anything. So there are different types of diving. You've got divers who work, say, for the police force or within the Navy. If you're more interested in the biology side of things, I mean, you could go on and be a diving instructor yourself. You could also then dive for a career in marine science. So it kind of depends on what type of diving you'd like to do. And I would strongly recommend the marine science degree because it's a very broad degree. It will set you up for a whole range of different types of jobs that might involve diving. Okay, so that would include things such as ecotourism. So you might be a dive master taking people on dives at resorts and that sort of thing, or you might be doing research and collecting data through diving. Okay, so what pathway would I take if I wanted to work with animals hands-on in a marine aquarium? Well, again, I would be taking, well, there's a few different ways of going about it. So if you did a Bachelor of Science degree or a Bachelor of Marine Science at Griffith, then you would have the possibility of potentially doing some research projects out at the Sea Jellies lab. So throughout our degree, you have the opportunity to do individual research projects, and sometimes those research projects can be done out in the Sea Jellies lab, and that's a great way to start to get hands-on experience. And in fact, some of our graduate students are actually working now at SeaWorld in animal training or in culturing. So some of our sea jelly aquarists, for example, are our Griffith graduates. Another question, is there many options to expand in your career? Yes, I think that the thing to remember about marine science or science in general is that it's not a very specific career pathway. So if you're a nurse or you're a teacher, for example, then you go into very defined roles using those degrees. With a science degree or even a marine science degree, in fact, there are lots of different areas that you can go into. And the degree that you do it really doesn't limit your opportunities. So there are a lot of people, for example, who might get into the marine science because they're interested in working on whales and dolphins, for example, but you actually find that in the end, you're really interested in developing policy, and so you might go down that pathway. So it's a very broad degree, and it gives you lots of opportunities to go into different areas. Even if you do a PhD is often thought to be a really specific type of qualification. But in fact, a PhD is really important because you develop a whole suite of different skills that are useful across a whole range of industries. So critical analysis and thinking, the ability to manage large data sets and to analyse data sets, the ability to write up reports and projects. Those skills are actually sought after across a whole range of industries. So there's a lot of people who go on and do a PhD in marine science and don't even end up working in marine science. They might go into the finance sector, for example, or banking. So yeah, I think there's a lot of opportunities to go in different directions, having the Bachelor of Marine Science as the starting point.
Well, thank you very much for that, Kylie. That was a fantastic session. So with that, I think we'll close off. And thank you again to everyone who's attended this session, our Careers in Marine Science session for Griffith University. Thank you.
Thank you. Bye-bye.